So for those of you who are watching last time, I got cut off right in mid-sentence. I was just describing a mass that is cooling. That mass would be expanding and therefore becoming lower potential. And so it would seek the lower potential environment that is farther away from the center of gravity, like the center of the Earth, for example. So, like the hot air would appear to rise because it is expanding, it's lowering its potential, it's cooling, and it's going to seek the lower potentials that are farther out in space. Okay, and if anyone has a question about that, just please send me a message and I can answer you there. Okay, so now, so hi guys, just welcome to the Zoom meeting. I just wanted to go around and see if anyone had questions to answer, and I think let's see. Let's start with Scott.
Hi, everyone. I just want to make sure that Sophia heard me. Yes, Sophia, you were correct. In the last meeting, I was wrong about the salt being heavier at the bottom. So I just want to make sure that I let you know that I was wrong.
Putting that on record. All right. Appreciate that. Any questions for you today, Scott? All right. All right. Next, let's go to Sophia. Hi, Sophia. Any questions or anything you wanted to talk about today?
No.
Okay. Okay. And then we'll go to Kirsty. Hi, Kirsty. Any questions? I think maybe you had a couple questions. I know you had some, and forgive me if I've lost track of what we have answered of yours already and what maybe we still need to answer. But anyway, I figured I would ask you.
Yeah. I have hopefully a quick question. I was wondering about the journey of the growth of the sphere from the disk. Does it go from disk to prolating to circle to then oblating, or is it go from disk oblating to circle to oblating? Because I've only seen it mentioned once, the word prolating.
I have a diagram I can show you. Let me share my screen here. Okay, you guys see this evolution of mass from plane to sphere? Yeah. Okay, it would start here and then go +1.
Yeah.
And so then the +1 series would be the prolating, which means going from this to then this to then this and to this. Then over here is the minus side.
And he's got oblateness written there too.
So right, so this would be from the 4 to the -3. That would be oblateness increasing. It would be bulging at the equator, and then
in the +3, he says oblateness
decreases, right? And so oblateness decreasing is the same thing as saying prolating or prolating increasing. Yeah.
So we should be looking at it side on for the plus side, and we should be looking at it in this orientation for the I don't know, to see the prolating, you have to turn your head.
So yeah, I have another diagram that I think will help. Give me 1 second because I have to pull it up.
The suspense is killing me.
I know. The greatness, Scott.
Oh my goodness, sorry.
Yeah.
Okay, share. Go share. Okay, do you see it now?
No. Oh, now we do, yeah.
No.
Okay.
I see it now.
Ah, yep.
Okay, good. Okay. Okay, so here we have the familiar Walter Russell periodic table, the kind of sine wave looking thing. And so when we zoom in, let's go to our favorite octave here and around the 4th and 5th octave. Now, okay, so here we go. So here we have our familiar octave
Lithium, our favorite,
where carbon is. So we all know carbon, this would be the 4++ position where the sphere is perfect. You see this yellow sphere. And here we have the +1, +2, +3. So +1 is lithium, and the 0 is helium. Helium is our inertial plane, essentially. That's the flat plane is where the motion would start winding up to lithium. So that would be prolating. So we see it's kind of, it would be two dimensionally flat at helium. It would prolate a little bit to lithium at +1. It would prolate more to beryllium at +2. It would prolate even more at boron +3. See, it's almost approaching this perfect sphere. And then it would prolate more until it was at carbon, the 4-4 position, amplitude position, perfect circle. And then, and remember, all mass has this life cycle. So it's born at helium. It grows to maturity. It's like a baby over here. It grows to maturity. This is like an adult, 45 years old. And then as they get older, 55, 65 years old, it's the -3 position. It starts oblating, starts bulging at the equator. And then at -2 oxygen, it's oblating more, even more bulge, getting flatter. And finally, fluorine, even more flat, more oblation, till finally we get back to the zero line, which would be, absolutely flat plane again. So this is kind of um, well, it's still two-dimensional, but you can see the prolation and oblation with the numbers of the formulas of the lock potential formula of the lock potential. So when our good friend Dr. Russell is showing this, he's just kind of showing it in a straight line, but in actuality, it would be closer to this. This is still two-dimensional. In actuality, it would be three-dimensional. As let's see, another thing I could show you would be the good old, we've seen this, let's see, where is it? I think here it is right here. We've seen this diagram before where it would actually be more like this in a three-dimensional space. There'd be one cone of mass winding up, meeting another cone of mass winding up. They meet at the 4++ position. This is where the perfect circle would be. But this would be, 1+, 2+, 3+, and then 3, amplitude, then 3-, 2-, 1-. And so that's kind of the three-dimensional version of it. This is the two-dimensional, colorful version of it. But this is just kind of explaining the different steps, but not really showing it in a three-dimensional way. Okay, does that make sense, Kirsty?
Yeah, that'll do for today. I'll think about it more.
Yeah. It's it's really this is just a general statement. Studying Walter Russell stuff, many of his diagrams, like this one, for example, that we see here, it's only explaining one idea. It's not the full picture, sometimes, but it's like, because it's like if he tried to explain the whole full picture, it's just like, could be overwhelming and too much. So he tries to break it down into pieces. And so this is just simply showing that it goes, each step through the formula of the lock potentials, it changes its shape. So, yeah. And then, someone else, and there's a lot of other kind of Russell things online that you guys can search, and someone was kind enough to make this. This is great, but, it shows with the periodic table, it shows the formula of the lock
No
potentials.
difference still.
Right. And it's the same thing. No difference, right? Yeah. But this, once again, is only in two dimensions, but it's really happening in three dimensions. In our true space. Okay. So
Because the prolating is happening. The
yes,
prolating is happening via the north and south poles, where the gravity is increasing via the north-south, and then the oblating is happening via the what you could call east-west. So via the equator. So you would expect it would have, you could draw it in some kind of difference in these little individual progression from plane to sphere. But
So
anyway,
yeah, let
maybe
me
I'll try and draw it.
yeah, so let me clarify one thing because you're bringing up, I noticed you brought up north, south, and east, west. And I think that is an important thing to understand is that he calls that universal direction. And he definitely, let's see, there's a diagram of that, which I think I have in here that I want to show you guys. So in terms of direction, so as he's explained, everything moves in a spiral. It's a spiral vortex. And so this is a picture from the universal one where he's talking about universal direction. All vortices turn from west to east and their apices point to north. So as we can see, um, we know that south is the beginning of motion, as in the picture that we showed here. The plane, that is the southmost point, is that inertial plane. And that inertial plane, when motion starts spinning, it starts spiraling, it heads away from that south point and it always heads towards north. Okay, now north will be at the center of the true sphere, at the amplitude of the wave. Okay, and so him showing this, he's showing how the vortex will it's pointing towards north. North will be in the center. Here he's got kind of a circle here because that would be like the center of mass, like the center of the sun or center of the earth. And so he says that, and let's see, here it is down here. Mass is accumulated around a vortex. A vortex is formed by the contraction of the axes of two opposing cones of energy. The greater the contraction, the greater the acceleration of motion within the vortex. Actually, that's not what I wanted to read right there. What I want to show is that you see there's a black line spiraling, and this is the direction of east towards north. When we say we're going towards north, we're going down here. We're going to the tip, of the apex of the spiral. North is right here. So with this black line is spiraling around, it's heading north by the way of east. And that's the gravitative stream, or a gravitative force is causing it to go that way. Now, the radiative force is the reverse, which he's showing as a dotted line. So that would be going from north, spiraling up, and it would be heading west towards south. So this dotted line is heading this way, the opposite way, because it's going up, it's going back to the south. South would be up here at the base of the cone, or the inertial plane. And so that is the universal direction for all matter. All mass is either flowing one way or the other. It's either heading north by way of east, east towards north, and that's the gravitative, or it's doing the opposite. It's radiating and it's going in the westerly direction towards south. So it's heading up in this case, towards south. And the dotted line is showing the direction of west. Now, that's just one cone. On the opposite cone, it's kind of the opposite way, so the black line here is still the east direction heading towards north because north is up here. So in this case, it's spiraling up. And the reverse is radiation spiraling downward towards the south direction. And it's going by way of west towards south is this dotted line. So that's universal direction. You can keep that in mind whenever we're talking about things like this. When we start from mass in plane and head towards sphere, we're going to the north direction by way of east. And when we are, I'm sorry, I did that backwards. Let me start one more time because it starts up here, the +1, +2, +3. So we're going down. This would be heading north by going down like this towards the sphere by way of east. And that's prolating. And then once it reaches here, it starts oblating. Oblateness increases. Now it's going south by way of west. So, I hope that was clear. I will, let's see. Okay, I got a thumbs up. I'm putting this up here one more time just for people watching the video later, to see this universal direction. And it's always all mass, everything, it always follows this direction. Okay. Now, that direction is going to look different depending on your perspective. When you're looking down at a spiral, it looks like it might be going clockwise, but if you're underneath that spiral, it'll look counterclockwise. So it depends on your perspective. It's an illusion of your perspective. But what he's saying is that it's always in this direction as he's described it. East, the direction of east towards north, or north by way of east, and then south by way of west, going west in order to reach the south.
I think I can see the prolating and oblating a little bit easier in these two spirals on the right. Sorry,
Yes.
4. So the starting position is this top one where the cones are fully within each other, and it looks like
Yes.
it starts by they pull apart. It looks like the waist is contracting. So I guess you could see that as a prolating kind of thing happening. And then when it's radiating, I guess the cones go back into each other like they are at the top, and that could be seen as oblating around the waist.
Yes.
Yeah.
Exactly. Great. It's so funny how, it's like how each person kind of sees it different. And it just takes like maybe one different diagram to like make it click in your brain, I'm so happy, Walter draws all these different diagrams, so he's really given us a lot of different perspectives of the same thing, and so in order to help make it click,
Mhm.
All right, guys. Well, it was great talking with you guys.
Thank you.
Yeah, we'll see you next time. All right.
Bye.
All right. Bye bye.